How do we determine the intervals in which a function is increasing or decreasing? Because in many applications it is important to precisely define where a function is increasing and where it is decreasing, so that we can find out some other important factors relating to the function. Because there are many other aspects which depend upon whether a function is decreasing or increasing and in what intervals, and what happens at the interface of those intervals where a function changes from increasing to decreasing or decreasing to increasing and so on. So that is why we have to define how exactly we are going to find out the intervals of increase and decrease of a function. How do we determine derivatives to do this? Let us look at how this is done. So before we do that, again we need to remember the most important thing. The derivative of a function is the general expression for the slope of tangent to the function at any and all the points on the graph of this function. So using this, we can define precisely the interval or increase or decrease of a function as follows. If you look at an increasing function and you draw tangents to some points on the graph of this function at an increasing interval of x, you observe that the tangent to the graph of this function at this point here has a particular slope, and at this point, which is greater than the one on the left, the tangent has a larger value of slope. And moreover, we also observe that the tangents have positive slopes, right? Because the tangents are making an acute angle with the positive direction of x-axis. Remember, the inclination of the tangent and therefore the slope of the tangent depends upon the angle that the tangent makes with the positive direction of x-axis. And we observe that both these tangents or any possible tangent that you can draw to this function will make an acute angle with the positive direction of x-axis. And therefore f is increasing in this interval. Let us look at another function which is decreasing, and again we draw two tangents as illustrations to show that these tangents make obtuse angle with the positive direction of x-axis, and therefore they have negative slopes. And therefore when a function has negative slopes for tangents, it is a decreasing function. Suppose f is continuous on an interval I and differentiable at all interior points on that interval I. If the derivative of the function is positive for all interior points in that interval, then the function is said to be an increasing function on that interval. Suppose f is continuous on an interval I and differentiable at all points in the interior of the interval I. If the derivative of the function has a negative value at all interior points on that interval, then fx is decreasing on the interval I. And the most important terminology which gets used in all the competitive exams, a function is said to be monotonic if it is either increasing or decreasing, not both. If it is monotonic increasing, then they call it so. Monotonic increasing, monotonic decreasing. And in general, it is said to be monotonic if it is only increasing or decreasing.